Right, in these next two examples, we're still technically doing the same thing. Our directions still say factor out the GCF of the polynomial. But in this case, our GCF is a little bit stranger. If we were to have a problem that said yz plus 3z, then can we see pretty easily that they both have a z in common? That's not too bad. Now, whenever we see something like this, though, we have a little harder time seeing it sometimes. But can you see that in my example, where I had a z, they have x squared plus 2? It's the same exact concept. Both of these terms, let me circle this so you can see it. This is a term, and this is a term. Both of those terms have an x squared plus 2 in common. So using that idea, we can factor out that common factor. Now when we do that, this times what would get us back to this term? Well, think about this term. This term says y times this binomial. So the binomial times y would get us right back to where we started. It's almost like if you were to divide that out, it would cancel out. Now, for the next term, because we have two terms there, the binomial times what would give us back to this term? Well, 3 times the binomial is the term, so a positive 3 times the binomial would get us right back to where we started. This is the factorization of that example. Let's do another one and see if we can see it a little bit better now. Here we have, again, two terms. Here's our first term, and here's our second term. What do they both have in common? Do you see that they both have a z squared minus 6? Absolutely. So now our task is to do that reverse distribution. Z squared minus 6 times what would get us back to this first term? Well, wouldn't that be an r? And then z squared minus 6 times what would give us z squared minus 6? Positive. Well, that would have to be a positive 1, because 1 times anything is itself. And remember from the example that we did earlier, you have to have that 1 as a placeholder, otherwise you could not get back to where you started.